Hey everyone, and welcome. Today, we're diving into a technology that's been quietly sneaking out of the nerdy workshops and, well, right into our homes. And it's poised to change not just how we make stuff, but where we make it. We're talking about a future where every single neighborhood could have its own little factory.
So let's start with a number $156.1 billion. Get this, that's the projected value of the global 3D printing market by 2033. To give you some context, that is more than the entire video game industry is worth right now. So, what on earth is fueling this kind of massive transformation? I mean, just look at the sheer scale of that jump on the chart. We're talking about going from around $28 billion today to over $150 billion in less than a single decade. That's not just steady growth, you guys. That is an absolute explosion. Figuring out why that's happening, well, that's what we're going to unpack today.
Right. Growth like that doesn't just happen. It means a huge fundamental shift is underway. 3D printing is officially graduating from being a niche hobby for tinkerers into a full-blown global industry. So first, let's just do a quick level set on the core tech that's making all of this possible. Okay, so at its heart, 3D printing is what's officially called additive manufacturing. And honestly, the best way to think about it is like building something with digital Legos, one tiny, precise layer at a time, all following a digital blueprint on a computer. It's the complete opposite of how we've made things for centuries, where you'd start with a big block of metal or wood and just carve away everything you didn't need. So with that in mind, let's talk about the actual machines. Because the hardware that's driving that $156 billion number is incredibly diverse. And believe me, it's where the real battles for the future of manufacturing are being fought as we speak. You really have two completely different worlds. On one side, you've got consumer printers that you or I could go out and buy for just a few $100s. On the other, you have these industrial behemoths that cost hundreds of thousands of dollars and build parts for actual jet engines. But here's the crazy part, and where the lines are starting to blur. Features that used to be only on those giant machines, like absolutely blistering print speeds, are now showing up on printers that cost less than an iPad. And these machines all work a little differently. FDM is the one you've probably seen. It squeezes out melted plastic, kind of like a super precise high-tech hot glue gun. It's amazing for cheap prototypes. Then you have SLA, which uses a laser to harden liquid resin. And that's how you get those incredibly detailed models with smooth surfaces. And then there's SLS, which uses a powerful laser to fuse together a fine powder, creating super strong, functional parts without needing any support structures at all. And all this technology reveals this huge strategic fight happening in the industry. You've got companies like Prusa on one side who are champions of an open source world, giving users total control to modify and tinker. And on the other side, you've got companies like Bamboo Lab creating this closed proprietary ecosystem. Think of them as the Apple of 3D printing, where everything is designed to just work right out of the box. It's a classic battle, right? Total control versus total convenience. But the biggest shift here isn't just in the machines themselves, it's in what we're actually using them for. And this right here is the turning point that's really putting the rocket fuel in that explosive market growth.
It's really an evolution. The whole thing started with what's called rapid prototyping, basically making quick, cheap models to see if a design works. Then companies got smart and realized, hey, we can print our own custom tools and jigs for our factory floors. But now we've hit the holy grail, printing end-use parts, the actual final pieces that go directly into the products we buy and use every single day. And you can see it right here. Yeah, prototyping is still the biggest slice of the pie, but look at that highlighted section. End-use parts, making the final product, is already over a fifth of the market, and it is by far the fastest growing segment. This signals a massive shift in trust. We're moving from using these machines for practice runs to using them for the main event. And why would companies make this shift? Well, the numbers are they're insane. Imagine being able to tell a factory manager you can slash their costs by up to 90%, or that you can reduce the time it takes to get a custom tool from weeks or even months down to just a few days. That's not just an improvement, that is a full-on revolution for the factory floor. Okay, so if the machines are getting cheaper and way more powerful, and they're now making real products we can actually use, what's the next logical step? Well, it's that the idea of the factory itself begins to change. We're starting to see a completely new model for manufacturing emerge from all this. This new model is called decentralized manufacturing,
And what that really means is instead of one single giant factory, you need to imagine thousands of tiny production centers. Could be small businesses, could even be individuals with printers in their homes, all connected together through one digital platform, ready to make things the moment they're needed. Let me give you a real-world example. There's a startup called MakeLocal that's building a platform to do exactly this. It connects people who need a part made with this huge network of printer owners or makers. The entire goal is to tap into the millions and millions of printers that are just sitting idle in homes and businesses right now. Think about it. All that dormant potential just waiting to be turned into one massive on-demand factory. And the process itself is incredibly simple. A customer just uploads their design and places an order. The platform's AI finds a local maker whose idle printer is a perfect match for the job. That maker accepts the job, prints the part, and ships it. And just like that, you have a product made on demand, not in some factory halfway across the world, but maybe just a few miles down the road. Now, this idea seems pretty simple on the surface, but its implications are absolutely profound. This isn't just about printing a custom phone case faster. This is about fundamentally redesigning the entire global supply chain as we know it. Think about it. The traditional supply chain is global, it's incredibly complex, and, as we've all learned the hard way recently, it is unbelievably fragile. It relies on huge physical inventories. This decentralized model, on the other hand, is local and on demand. And here's the most powerful shift. It replaces physical warehouses full of products with digital warehouses full of files. You're not storing the object, you're just storing the blueprint. So, why does any of this actually matter to you or to the country? Well, it means way more secure supply chains. It means we can respond instantly to a crisis, whether we need to spin up production of medical supplies or critical defense components. It empowers local economies, turning anyone with a printer into a potential manufacturer. And frankly, it's just a more sustainable way to do things, with a whole lot less waste and a lot less international shipping. And that really leaves us with one last big thought. We always think of industrial revolutions as these things that happen in giant, noisy factories. But what if the next one is already here, quietly sitting on our desks, in our garages, and in our workshops, just waiting for all of us to flip the switch? Thanks for tuning in.